Okay, let's give you guys some more practice. So somehow work out this area here. Somehow work out this area here from 1 to 3, from 1 to 3. But bear in mind that dead on 3, this whole thing breaks down. You've got a vertical asymptote here. Dead on 3 it breaks down, but somehow work out this area. So press pause and have a go. Okay, so to do this, we need to somehow integrate this. To integrate this, we're going to rewrite this. So we're going to rewrite this as two separate fractions. We're going to rewrite this as two separate fractions. So we've done this before. So the trick is to rewrite this as two separate fractions. And then our job here is to find A. Our job here is to find A and B in such a way that the combination of the two here will be the same as this. So here we would times top and bottom by this thing here, x minus 3, x minus 3, and then here times top and bottom by this thing here, and then the two denominators will be the same. Merge them together, that will then give you this, and then it's blah blah. We've done this before, so as it turns out, but when you get to this stage here, you're trying to find A and B in such a way that this whole thing here will be the same as this thing here. Well, this thing here is a constant, so this here is a constant, and then you can imagine this as being 0x. So you've got to find A and B in such a way that the coefficient, this contains x here, this contains x here. You've got to find A and B where this thing here matches up with the 0, and then this here matches up with this 3 here. Well, as it turns out, if you put minus 1 into the A here, then this thing here will match up with this 3 here. And then if A is negative 1, if you put negative 1 into here, then if you look at this, the coefficient here of this x here is 0. So you've got to B has to be 1 in order for you to have a 0 here, because we want this to match up with this 0 here. Blah blah blah. We've done this before. So A must be negative 1, B must be positive 1. So you can rewrite this as this. So that means you can rewrite this as one fraction, take away another fraction. So you integrating this will be the same as you integrating this. But the thing is, we can't really integrate from 1 to 3, because dead on 3 it breaks down. So we're going to integrate it from 1 to B, and then later on we can allow B to head towards 3 from the left hand side. Okay. So we are going to integrate it from 1 to B. So integrating it from 1 to B. So now it's just a matter of integrating this. Integrate this. It will give you the absolute value of x minus 3. Integrate this. It will then give you this from 1 to B. So now remember natural log of A over B, that's the same as natural log of A minus natural log of B. So we can combine these two together. That will then give us this. So now we can put this into here. That will then give us this. Put it into here. That will then give us this. Take away. Now put this one into here. That will become negative 2. Put 1 into here. That will then be, well, it will become negative 2. But then absolute of negative 2 will become natural log of 2. So natural log of 2 here. This thing here is the same as natural log of 2. So now when you integrate it from 1 to B, it will give you this answer here. But now we're going to let B head towards 3 from the left hand side. So allow B to head towards 3 from the left hand side, meaning take the limit of this whole thing here. Take the limit of this whole thing here as B heads towards 3 from the left hand side. For the minute you allow B to head towards 3, you are no longer integrating from 1 to B. You can actually say you're integrating from 1 to 3, because you've taken the limit as B tends towards 3 from the left hand side. So you can actually say you're integrating from 1 to 3. Well, if you allow B to head towards 3 from the left hand side, this thing here will become this. This whole thing here will become this. we can forget about the limits here because this is a constant, and we're allowing b to. It is a b that's moving about. This thing here doesn't contain b, so we don't really need to take the limits as b tends to 3 from the left hand side. We can just leave it as a constant. Now, if you look at this, as b heads towards 3 from the left hand side, this thing here will head towards 0, because as you head towards 3, this is going to head towards 0, 0, and then this thing here is heading towards 3, 0 over 3. This thing here is going to be 0. So if you look at the natural log graph, as you're heading towards 0, this whole thing here will head towards negative infinity. And then you take away a number that's negligible, so you can pretty much forget about this small constant. So you are heading towards negative infinity. That means here the area here diverges. It doesn't come to an absolute value. The area here just gets bigger and bigger and bigger in the negative direction. So it doesn't converge basically. Okay.